We are told the doubling period of a bacterial population is 25 minutes. After 100 minutes, the bacterial population is 5,600. What was the initial population? So when we're dealing with some population that's doubling every certain amount of time, what we're dealing with is exponential growth, which can be summarized by this equation right here. P of t, the population at time t, is equal to p sub 0, so the initial population, times 1 plus r, where r is the growth rate, to the power of t, where t is the time. So for this example, we're trying to figure out what was the initial population. So we're trying to solve for p sub 0. So let's see if we can fill in some values. We know that after 25 minutes, this bacterial population will have doubled. So what we can say is that p at 25 must be double or 2 times the amount of the initial population, p sub 0. So we don't know what this initial population is, but we know that at 25 minutes, it must be 2 times the initial population. Now the trick here is we're going to try to rewrite this equation to match this format. Because what we'll find is if we can match this format, it becomes pretty easy to solve for p sub 0. So if we want, we can write p at 25 is equal to, let's write p sub 0 first. So we'll say p sub 0. Now remember, we want the rest of this equation just to be times 2. So we can say times 2 to the power of, if we just want this to be 2, then it must be to the power of 1, because 2 to the power of 1 is just 2. So what we can write is t, but in this case we're saying t is 25. So what we can say is t divided by 25. Because really if we plug in a 25 for t right here, we just have 25 divided by 25, which is 1. So this is how we can rewrite this initial expression right here in this format. Okay, here's what else we know. After 100 minutes, the population is 5,600. So at p of 100, we're at a population of 5,600. So what we can say is that 5,600, if we want to write it in this format right here, is equal to p sub 0 times 2 to the power of t. Now t in this case is 100. That's how many minutes we're at. So 100 divided by 25. So now that we have this formula, we can solve for p sub 0, the initial population. So let's do that. So we get 5,600 is equal to p sub 0. Now 100 divided by 25, that's 4. So this is really 2 to the 4th power. Now 2 to the 4th is 16. So we have p sub 0 times 16. So to solve for p sub 0, we just divide both sides by 16. And we'll find that 5,600 divided by 16 is 350. On this right-hand side, these 16s cancel out. We're just left with p sub 0, the initial population. So our final answer is 350. This is what the initial population must have been. Now, for this particular example, it's pretty easy to double check that we got the right answer. So if we say that p sub 0 is 350, if we keep doubling this amount every 25 minutes, let's see if we actually do get to 5,600 after 100 minutes. So after 25 minutes, this population should have doubled. So it would be 350 times 2, that's 700. Now, after another 25 minutes, or a total of 50 minutes, we should double again. So 700 times 2 is 1,400. And then after another 25 minutes, so up to 75 minutes total, we should double again. So 1,400 doubled is 2,800. And then if we double again after another 25 minutes, now we're up to a total of 100 minutes. And 2,800 doubled is 5,600. So that checks out. So that's just kind of a way to double check that we got the right answer.